Welcome back. This is our lesson 36. I want you to be very keen because what we are discussing right now tends to confuse some of the learners I do meet. It is none other than proof by induction. It is none other than proof by induction. Now, there are two words here. There is the word proof, which comes from proving, or one comes from the other, if I may say. Then there is another one, induction. Induction comes from the word induce. Induce is like introducing something that has not been in a certain thing. I may refer to layman's perspective. It's like having a male goat mating with a female one, and one conceives. That process, there is an induction that has taken place, and after some months, a baby goat will come out. Now, what comes to this is none other than what I'm going to give. It is a process of introducing a term, in bracket terms. It can be one single term or more than one of them in a given series to prove a similar term given. To prove a similar term given. To prove a similar term. Now, the similar term given and the one and the one that has been introduced will end up almost having the same line as the original one. The same line as the original one. As the original one. What does that mean? What that means is you are given a series, you are told to prove that series by induction. You keep introducing various terms, but the terms you introduced must be in a position to generate either a similar term to the original series given, or at times it can even be the same one together. So, we can use proof by induction to prove summations. Proof by induction can be used to it can be used to prove summations of given series. It can be used to prove that a given number is a factor or a multiple to a certain term to prove that a given number is a factor or a multiple to a certain term. It can also be used to prove that a certain number is divisible by a given term. We can keep it at that. I've said, or I've introduced it by explaining what it means and some of the applications where you can find it. They can tell you to prove that 6 power n minus 1 is divisible by 5. How are you going to prove it? That's what we are going to show. They can tell you to prove that a certain number, it can be 6, is a factor of a given term. Maybe 8 power n plus 7 n plus 3, something of that kind. So this is what we are going to look at. They can also tell you to prove a certain summation of a given series. It can be summation to prove that the summation of squared terms from 1 up to n is equal to 1 over 6n plus n into n plus 1 into 2n plus 1. So it depends on which one they have given you. Let's look at some of the examples. Examples. Prove by induction. That a half plus 1 over 6 plus up to plus 1 over n into n minus 1 is equal to 1 minus 1 over n. You'll find something like that, and they are telling you to prove it by induction. They're telling you to prove it by induction. This is the process you're going to go through. So you start with for n is equal to what? N is equal to 2. Why have I started with a 2? If I press a 1 here, someone may ask why not a 1? If I press a 1 here, I'll end up with 1 over 0, which is meaningless. So I shift to the next integer, and that integer is none other than 2. Now, for n is equal to 2, I'll look at the term on the left-hand side. This one is left-hand side, mathematicians. So we have 1 over, in the place of n, on my left-hand side, I'm substituting in this term. I'll have a 2 into 2 minus 1. In the place of n, I'm pressing there a 2. Now, this one will give me 1 over 2. Because here, I have 2 minus 1, which is a 1, times 2, that one gives me 2. So in the denominator, I have a 2. In the numerator, I have a 1. I can also look at the right-hand side. Now, in my right-hand side, I do have 1 minus 1 over 2. Now, 1 minus 1 over 2, what does this one give me? Under the same LCM, I have a 2. So 1 goes into 2 times 1, that one is 2, minus 1, which is 1 over 2. You can see that on introducing a 2, or on inducing a 2, or on substituting a 2, on the left-hand side, I'm getting the same term, just like on the right hand side. So I will say it holds for n is equal to 2. After that, I can go for n is equal to k. Now for n is equal to k, the uniqueness about this step, you have to write down the entire series, but replacing n with k. I've said you rewrite down the entire series and its summation, but replacing n with k. So we have a half plus 1 over 6 plus up to plus. Now here I have 1 over k into k minus 1. That one is equal to, the other side I have 1 minus 1 over k. Since I've just replaced n with k, I'm not going to simplify anything here. So I will just say it holds. It holds. So after this step, you go for the next term after k, and that is none other than k plus 1. That's the next term after k. For n is equal to k plus 1. Now for k plus 1, what are we going to do? We shall first write down the expression or the series when n is equal to k. That is, I have a half plus 1 over 6 plus up to plus 1 over k into k minus 1. Then plus, you substitute for n is equal to k plus 1. You are going to substitute it here. Now, in the place of n, I've said you substitute k plus 1. So I'll have k plus 1. Then into here, you have k plus 1 minus 1. All of that is equal to 1. You come back here, you have 1 minus 1 over k. It is, the space may not be enough. This one is equal to 1 minus 1 over k plus this, it is 1 over k plus 1 into k plus 1 minus 1. I don't know whether that is visible, but let me try to ensure that everybody can see it properly. It is k plus 1 into k plus 1 minus 1. Now, at this step, you only focus on the right hand side. Simplify the right hand side. I mean the terms on the right hand side. That term, we have 1 minus 1 over k, then plus. Here we have 1 over k plus 1, 1 over k plus 1. Then there is this one cancelling with that one. That means here we are remaining with k, isn't it? So since we are remaining with a k there, I've said simplify the right hand side, and that's what I'm doing. I'm going to maintain this one because what I'm proving, the one must appear as a 1 on its own. Now, if I'm to maintain that one, I have a minus, I will introduce a bracket. So if I introduce a bracket, since this one has been negative, the bracket will not affect it. The bracket is going to affect this term, which is positive, and it will become a negative now. So we have 1 over, I can start with k into k plus 1. Now, when you look at these two, those are fractions. Those are fractions. So we have 1 minus 1 over. So since they are fractions, we are going to apply ways of simplifying fractions. The LCM is k into k plus 1. The LCM is k into k plus 1. Why? We have a k here and a k into k plus 1. So we take that one which houses the 2. So k goes here, k plus 1 times, then minus 1. Okay? Now, this is 1 minus. When you look at this, it will cancel with that. So you remain with k over k into k plus 1. The k here cancels with the k1. And the k up will cancel with the k down. So you remain with 1 minus 1 over k plus 1. Now, are you seeing that after simplifying the right-hand side, the term that we have ended up with is similar to the original term in our series, the summation of this series? When you look at this, in the place of n, we have the k plus 1, which we introduced. Altogether, we have that we introduced. I want us to look at, I want you to try others. I want you to try others. Like you can be told to, like, we have number 2. Number 2, we have proof by induction that 6 to the power n minus 1 is always divisible by 5. We are proving that that one is always divisible by a 5. Now, how do we prove that? We can let p n to be equal to this term, which is 6 to the power n minus 1, and we divide it by a 5. Because they are telling us to prove that this one is always divisible by a 5. So, for n is equal to 1, we have p1 is equal to 6. When you power here a 1, you remain with a 6 minus 1 over 5, which is 5 over 5, and you get a 1. So you can say it holds. Because indeed 5 is divisible by what? By 5. Then we can go for n is equal to k. So for n is equal to k, you have pk is equal to 6 power k minus 1 over 5. Now at this level, you can make 6 power k the subject. You make 6 power k the subject. You make it the subject. So if you make it the subject, we do have 6 power k is equal to 5 pk plus a 1. After making 6 power k the subject, then at that level you can go for n is equal to k plus 1 and see how this expression behaves. This is all about proof by induction. You can try others at large. You can see how they behave. There are very many summations, there are very many factors, there are very many multiples. So it's a matter of trying. We are going to see some in our prep work. We shall pick it up from there.